When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
If I were to tell you that this here would be our chlorine ion, so this is our chlorine ion, and this is our hydrogen ion, we have two different types of beakers. If this beaker which has 2 chlorine ions and 2 hydrogen ions, and this beaker which has 5 chlorine ions and 5 hydrogen ions. Which one of this one is stronger? So which one has a stronger acid and which one has the weaker acid in it? And that's one of the big problems when it comes to mistakes or common mistakes that people make. They think that, because there's more in here, this one's going to be the stronger one. There's less in here, that's going to be the weaker one. But for acids, it's a bit different. The way the actual definitions work is a bit different. And we have to realize that it's not the strength, they're still both hydrochloric acid. They're both just as strong. They're both just as strong. In this case, we're just talking about how concentrated there is. This is the concentration. So in this case, this would be the dilute version, and this would be the concentrated version. But they would be both strong acids. They wouldn't be weaker or stronger. So when it comes to weakness and weak and strength, so weak and strong acids, we do need to know the actual definitions. And we'll go over that in a second. But for the dot point itself, the reason why I'm mentioning all this is because the dot point itself says describe acids and their solutions with the appropriate use of the term strong, weak, dilute, and concentrated. So there's 4 terms you should know. Dilute and concentrated, which we mentioned earlier, were if one has less particles in it than the other one. And then this idea of strong, weak. I'm going to go over that in a second as well. So first we'll go over just what strong and weak meant. And we said often that hydrochloric acid is a strong acid. And that, for example, ethanoic acid is a weak acid. So this is a weak acid. Now why are they weak and why are they strong? Well, if you have a look at hydrogen chloride when it comes in contact with water, what will happen is this means it's a one-way, so it's a to completion. The arrow means it's not a reverse reaction, it's to completion. And here we have all of our actual hydrogen ions coming off, and this being completely dissociated. So you can see here, all of them are in our chlorine and hydrogen ion forms. There's nothing left of that original hydrogen chloride. These molecules have all separated. So here they're all separated. So you can see we had 5 originally, and now they're all separated. Whereas if we have a weak acid, what actually happens is not all of them separate. So here we have our acetate comes in contact with water, and if it donates a proton, then what will happen is it will become ethanoic acid or acetic acid, and it will also give off this hydrogen ion or hydronium ion. Now if you look at the actual reaction, you see, okay, well this one has lost its hydrogen ions, this one has donated its hydrogen ion to one molecule, whereas the other ones, this one is still intact, this one's still intact, this one's still intact, and this one's still intact. So overall, this one is actually a weak acid. And the reason why it's a weak acid is because it didn't donate, not every single molecule in that mixture has donated its molecule, its proton. Only one has, so 1 in 5. In this case, 1 in 5 has donated. Whereas with hydrochloric acid, there were 5 in it, 5 and 5 donated their protons. So that means the actual hydrochloric acid is a strong acid, especially compared to ethanoic acid, which is a weaker acid, because not all of them dissociated. So we can use that word dissociated. Not all the ions dissociated. There are still some of the original molecules left. Only one actually donated its protons, whereas for the other one, all of them did. And that was the word strong and weak. So if something's a strong acid, that means most of them have dissociated into the ions. Whereas if it's a weak acid, then only a few of them actually have dissociated into the ions. Many of them are still in their original structure. Now when it comes to dilute and concentrated, when it comes to dilute, we for example often say that now if you have just a few molecules in it, then it's dilute, compared to if there are lots in the actual molecule, lots in there, then they will be concentrated. So for example, if we say we have 0.1 molar of hydrochloric acid compared to, so this might be 0.1 molar, and this might be 1 molar of hydrochloric acid. And molar is obviously a measure of concentration. Both these would be just as strong. So the strength of the acid would be just as strong. Because remember, the actual equation would be this. Hydrogen chloride plus water goes into hydronium ion and chloride ion. And this happens for both the cases, so they're both just as strong, and they both donate just as many as both these examples donate all of their protons they have. So the strength-wise, they're the same. The only difference is the concentration. So the concentration in this case is 0.1 molar, and in the other case it's 1 molar. Because in this case there's just more of them. So if it's more concentrated, whereas the other one is less, so it's more dilute. But overall, strength-wise, because they're both the same acids, they're just as strong. And so for this dot point, you should be able to describe acids in a solution for the appropriate use of the term strong, weak, dilute, and concentrated. So these come in pairs. They're either going to be strong or weak, or they're going to be dilute or concentrated. And you should know, you should not confuse strong and weak with dilute and concentrated. Strong and weak. So strong just means that all of the actual original molecule is dissociated into its ions, whereas weak means that only a few might have actually dissociated. Dilute means that there's going to be less particles of whatever acid we have in the solution, whereas concentrated means there are going to be more particles in the actual solution. So these are the main parts from this dot point. I hope that was useful.
Thank you for watching.